Hello, everyone. My name is Sonia, and today I will be sharing my presentation on Introduction to Scientific Research. I'll just give everyone a few minutes to join before I officially begin my presentation. And if you can, I would appreciate it if you let me know what grade you're in and where you are joining from. Okay, thank you for sharing, Havisha. It's really cool that you're in New Jersey. I'm also a rising senior. Nice to meet you, Tisha. That's cool. You're also joining from New Jersey. We have someone from Virginia, Los Angeles, New Hampshire. It's really awesome. Okay, so I will wait another minute and then I'll start sharing my slides. So I see that there are a lot of rising seniors, so it's really cool. I'm also going to be starting my senior year this fall. Okay, can everyone confirm that they're able to see my screen when I'm sharing it? And then I'll get started on my presentation on research. Okay, awesome. Thank you everyone for saying that you can see it. I will go ahead and begin my presentation. Okay, so as you know, this is part of the Young Scholar Program, and today I'll be presenting my presentation on conducting scientific research. So just as a disclaimer, the information used in the presentations Young Scholar Program give the author the right to not be responsible for the topicality, correctness, completeness, or quality of the information provided, but it is a tool for understanding the concepts. Okay, so before I begin my presentation, I want to give a little bit of background on who I am. So my name is Sonia, and I am passionate about studying medicine in the Medical and Health Services Academy at my school. And I'm currently a rising senior at John C. Kimball High School in Tracy, California. And I am participating in an internship called PIPS, which stands for Pediatric Internship Program at Stanford. And I also have some certifications for Oracle Cloud Infrastructure and Generative AI. At High School Navigator, I am the Technology Officer / Career Development Coordinator, and this is my third year as part of the Young Scholar Program and High School Navigator team. So before we get into the content of this presentation, I would love to know what your experience with conducting research is, whether you are very familiar with it or what type of research you know about, what type of research you have done on your own, or maybe if you haven't done research, what you are interested in researching. I'll give everyone a few minutes to just respond what their experience with research is and how familiar they are. And while I'm waiting, I can just give some background information on why I think research is really important and can be beneficial for students. So, as a student interested in pursuing a career in biological sciences and eventually pre-med, research is a great way to just get familiarized with the environment, like the lab environment, but also maybe like dry lab environment. And it's definitely something that has gained popularity, and students are starting to do it in high school and undergrad, as well as it's necessary to get your master's degree when you write a thesis, and also when you're doing your if you're doing a PhD, a lot of what you're doing is research, and your final dissertation is another form of research. It's when you've published all of your work in a large paper. Okay. So I see Zadie said that she has no idea, but that's okay because today it'll be great. We'll learn a lot about how research is conducted and different forms of research and research design. Okay, so I will continue with my presentation. So this is just an example of a research poster, the top half of it. And I just wanted to put this on my PowerPoint to show you what an example of research can look like. In my experience at the pediatrics internship program at Stanford, we are working on writing research posters, and this is one form of writing down our results and also our process. So as you can see in this poster, there's a background section and objectives, methods, results, and then there's also at the bottom a conclusions, limitations, and future directions topic. So for the agenda today, I will discuss the scientific method, how to develop research questions, what the different areas of research are, the different designs that there are. We'll go over basic statistics, which is important for analyzing your data, but also important when reading different research papers and understanding what the statistics represent. And then also how high school students can get involved in performing research. So the first step in any research project will be understanding the scientific method. And this is important because this is the approach that you use for all research projects. And it follows the same set of basic steps. So the first step would be to identify research questions and aims. And then you would determine your hypothesis or hypotheses, and then your methods to address the hypothesis and aims. Then you would conduct an experiment, you would collect data, perform an analysis on that data, look at your conclusions from the experiment, look at the limitations of the study, and then potential implications of the research. It's also important to note that often in the scientific method, if an experiment does not give proper results or does not lead to the information or the outcome that one was looking for, it's often a very normal step to have to go back to the beginning and having to create another experiment and going through the different scientific method until you have reached your conclusion. So now I'm going to explain how to develop research questions and to make sure that they are smart questions. So it's important to develop research questions as they drive the entire research project. Number one, it's important to be specific and state exactly what you need to achieve in the question. Next, the goal must be measurable. So the research question must include a quality or a quantity measure. It must be achievable and realistic. It can be challenging, but it still must be achievable given the resources that are available. And it must be time bound, having a clear end date or time scale. For example, in my internship, I had 6 weeks, so it was important that I established a research question that I could conduct research on in the time that I had. So when developing research questions, it's important to progress from the general to the specific. So you should present the general subject or problem and then review the literature that is currently available on the topic, specifically what is known and what is not known, and then understand what your argument is in the context of other people's work, and then what is the aim/research question of the study that you would like to conduct. This is very important because before you ask a question, it's important to know if this has already been answered or if this is a new topic that can be further investigated. And if anyone has any questions during the duration of this presentation, please feel free to put it in the comments or the chat and I will take a look. So when refining your research question, it's important to follow the steps as outlined in SMART. So for example, if we have a very simple question like why did the chicken cross the road, it's important to understand that this question does not address which chicken or which road, and also is a question that could be answered by hypothetical internet search, meaning that this would not be a very specific goal or would be something that needs much research on. And then you can also add to that by saying how many chickens crossed Broad Street in Durham, North Carolina on February 6th, 2014. And this question could be answered in one sentence and does not leave room for analysis. So again, when developing research questions, it's important to go through the steps of understanding if it is specific, if it leaves room for lots of analysis, and if it can be properly and thoroughly investigated. So a good way to pose this question would be, what are some of the environmental factors that occurred in Durham, North Carolina between January and February 2014 that would cause chickens to cross Broad Street? Of course, this is just one way to ask this question, but it can lead the author to taking a stand on which factors are significant and gives the writer lots of room to argue to what degree the results are beneficial or detrimental. So just something to keep in mind when developing research questions. I'll take a look at the chat to see if anyone has any questions, and then if not, I'll continue with the areas of research. Okay, it looks like there aren't any questions, so I will continue with the presentation. So for the areas of research, there's basic science, clinical research, advocacy, global health, medical education, and quality improvement/performance improvement. So here are some examples of the type of research that can be done in each area. So for basic science, someone can perform research on animal models, cell cultures, or bioinformatics. For clinical research, someone may perform research on retrospective chart reviews or health services research. And advocacy can look like community-based participatory research or health services research. And then for medical education, this can be similar and also looking at retrospective chart reviews or clinical trials. And then can also be needs assessment or curriculum development or program evaluation. And for quality improvement or performance improvement, people can run effectiveness analysis or statistical processes to evaluate the quality or performance of a certain procedure. There are also different types of research designs that are available that scientists will use researchers will use based on the research question they're trying to answer. So there's descriptive research, experimental research, correlational research, diagnostic research, and explanatory research. So just for a brief definition of what these different types of research designs would entail, a descriptive research would help provide answers to the questions of who, what, when, where, and how associated with a particular problem. An experimental design would look at the process of carrying out research in an objective and controlled fashion so that precision is maximized and specific conclusions can be drawn from a hypothesis. And for correlational research, it's specifically looking at how two variables are related to each other. And the researcher may control or manipulate them to see the effect of the variables on each other. And then for diagnostic research, it would be to evaluate the cause of a specific problem or phenomenon. And explanatory research is a method developed to investigate a phenomenon that has not been studied or explained properly. So to give a little bit more explanation on examples of descriptive studies, there could be historical or archival studies, naturalistic or observational studies, and case studies. In a historical or archival study, you could look at past school records to see if asthma rates have changed over time as new medications have developed. And for naturalistic or observational studies, this could be through watching and writing down how many teenagers have asthma and how many take medications for it. It can also be through perhaps an interview and asking people and observing them. And then for a case study, this is an in-depth study describing a person. And an example would be someone with asthma and looking at their medication history. Case studies are often done on specific individuals who may have a rare case, and the research obtained from such studies is often not generalizable to the general public, but can give specific information on a specific case. So when incorporating time into your research design, you can have a cross-sectional study in which you take measurements at only one point in time, or a longitudinal study in which you take measurements at two or more points in time. And before I continue, I just want to give some important definitions of an independent variable and dependent variable, as they are very important to setting up an experiment. So you probably already know, but an independent variable is the variable that you manipulate or change. For example, in the diagram on the right, it would be the treatment with active medication versus the treatment with inactive medication or the placebo. And this is often a predictor variable as it predicts the study's outcome, and then the dependent variable would be the effect, and it would be the response of the participant. And it depends on the independent variable. So there are also different types of designs in terms of the subjects. One design is called a between subjects design, and in this design, each participant is in only one group, and a participant can be in the treatment group or the control group, but not in both. So as you can see in this table, the participants are numbered from 1 to 100 in the left column, and here these patients would receive the asthma medication, but then the second 101 to 200, would receive the treatment as usual, and this would be the control group. And this is just saying that in a between subject design, you would compare results between subjects. You would have a separate 100 and then another 100. And then another version of this design would be a within subject design, where all 200 participants are given both the asthma medication and the treatment as usual, so the regular and the specific treatment. And this is a way to directly compare the results of the medication and the regular treatment on the same exact person, so you can specifically compare how did the two treatments affect the specific participant. And when this type of study is done, usually if the asthma medication is given, then participants would have their full trial of 6 weeks, and then usually wait a few weeks to make sure that all the effects of the new medication are gone, and then provide the regular treatment or the control group treatment, just to make sure that both effects are properly compared and none is affecting the other. And often in experiments, it's important to have a repeated measures design where participants are measured repeatedly on the same outcome variable. So participants would be treated as a within subjects design, statistically speaking. So, for example, with the asthma attack example, you would measure the number of asthma attacks during treatment, all of these time points to properly take measurements of what is happening at each phase in the treatment. So it could be 1 week, 2 weeks, 1 month, 3 months, 6 months, and then after a year. And this provides some information on how people are doing while they're progressing through the treatment. So then when people are being evaluated after the studies, there are 3 phases. So there's the pre-post study, and this is giving people a survey about their asthma symptoms before and after medication and comparing. But there's also the comparison group treatment where one group gets asthma needs, other group does not, and it's not randomized. And for a randomized control trial, which is often optimal, it's randomly assigned people or groups receiving the medication or control, and then they would be compared. And for this, it's important to have a representative sample of people who are being assigned the treatment and the control. So something that is important to consider when comparing or evaluating results is that correlation does not imply causation. So for example, if there are 2 variables like drowning and ice cream, it's important to understand that just because there may be some correlation between the incidence of kids drowning and people eating ice cream, that doesn't necessarily mean that one is causing the other. So instead, there could be another factor that is the associating both variables. So for example, heat could be the main factor because on a hot day, when kids are eating ice cream, they're more likely to go to the swimming pool and drown. So that is an important thing to keep in mind, that correlation does not imply causation. So in an experiment, there are different features. So first, you must manipulate or change something. Example would be the type of treatment for asthma. And then there must be a control group, as you saw in the previous slides. And no treatment or treatment as usual could be the control. And for participants to be randomly assigned, as well as this is important to allow for being able to draw conclusions about the cause. So for the research question, does a new medication lower asthma rates in people with asthma? An example of how an experiment would be run is that first participants would be selected and then randomly assigned to groups. One would be the treatment group, the next would be the control group. That would be the independent variable, and then the dependent variable would be the measure of the number of asthma attacks faced by the people, and then data would be analyzed to draw conclusions. So I'm going to check in to see if anyone has any questions at this time. Okay. And if anyone does have any questions, again, you can post them in the chat. Okay. So I will continue. Okay, so for basic statistics, first let's understand why it's important to understand statistics, or at least have a basic understanding. So one, for scientific research, it is often used to ask and answer questions. For example, what percent of 18-year-olds have ever used e-cigarettes, or how does remote learning affect student engagement, or is maternal cannabis use while pregnant associated with the baby's birth weight? So in all of these questions, statistics are somehow involved or would be involved in the answer to these questions. So it's important to understand what they would mean and how they would affect the results of these questions. And additionally, statistical methods are tools for answering scientific questions, and it's important to use the right tool for the correct question posed. Additionally, Statistics are important to inform decisions, treatments, and policies. For example, if you ask the question, does banning e-cigarette flavors reduce adolescent use? And the outcomes show that by banning them, less adolescents are using e-cigarettes. This can have implications for treatment and policy. And before any major decisions can be made of this from this data, it's important to have statistics that prove that the effects of banning the e-cigarette flavors. Similarly, it could be important for a question like does prescribing drug X reduce the risk for heart disease? Additionally, it's important to understand statistics for science literacy. Often lots of information is misinterpreted, and knowing how studies are designed, analyzed, and summarized makes all of us better consumers of research, so we have a better understanding of how to read the research and use it and make sense of it. For example, a pediatrician would review research to make informed treatment decisions for their patients. So typically when we are looking at questions for statistics, we're typically wanting to know three main things about understanding data. What type of data is it? How can we describe the data? And what does our data tell us about the broader population? Specifically, can the data be generalized to a larger population? So you might already know this, but there are two main types of data, qualitative and quantitative. Qualitative data would be non-numerical, words rather than numbers. They could be information from an interview or a focus group, or information collected by asking parents something. Like, what are your main concerns regarding the legalization of marijuana? There are also subjective interpretations of this data, so it's important to just look for the broader themes when evaluating this. For quantitative data that is numerical, it is analyzed using statistical methods, and it can be final exam grades or the population of Canada, just something that is very specific. There are also four types of quantitative data that I will describe. So first, there's nominal data, and this is data that falls into categories and it has no particular order. Specifically, this can be your state of residence, California, New York, Arizona, Texas, Florida, and so on. And for the next type of quantitative data, that would be ordinal data, and this is data measured on a scale that is ordered, and the intervals between ranks are not equal. So it can be like class standing or military ranks, like private, corporal, and sergeant. So here in the image, you can see that for nominal data, there are different types of stationery like pen, pencils, and erasers, as well as animals. And for ordinal data, we have how someone is feeling and different emojis describing that. The next two types of quantitative data are interval and ratio data. So interval data would be measured on a scale that is ordered, and the intervals between ranks are not equal. And something that distinguishes interval data from ratio data is that there is no true 0 point. For example, with IQ, there's no true meaning behind 0 IQ, and same for temperature in Fahrenheit. For ratio data, this is measured on a scale that is ordered and the intervals between the ranks are equal. There is a true 0. So specifically for height, that would mean that that object doesn't have any height. And it can also be used for age as well as GPA. So before I continue, I want to ask everyone in the chat, which of these types of data have you heard of before that we just discussed? And are you familiar with using any specific form of data in your life? I'll just give everyone a chance to respond. Okay. It could be the 4 types of data that we discussed, or just any other types of information that you usually use in your everyday life. Oh, okay. So Khadija said, I've heard about quantum data, but I've never had any experience with it. So that's interesting. And if anyone else has experience with data, they could also post it in the chat. But if not, I can continue with my presentation. Okay, I'll continue. So on this slide, we can see some information on athletes and their nation, their rank, and their time in hurdles. So we can look at this data and we can categorize the nations as categories and with no order. So those would be types of nominal data. The rank would be ordinal data because it's ordered. However, the intervals are not equal, so we don't know what the exact difference would be from 1 to 2 or 2 to 3. And then for time, this would be ratio because it's ordered and the intervals are equal. And there's also a true 0 at 0 seconds. So now I'll explain why data type matters. So different types of data are analyzed and presented in different ways. So nominal data, which is based on categories, can be presented in the form of a pie chart, as shown here with the number of medals won by country for the US, Canada, China, and Jamaica. And ratio data, which is different, can most likely will be best represented with a bar chart, as shown here with the athlete on the x-axis and the time in seconds on the y-axis. Now I'm going to talk a little bit more about what descriptive statistics is and its importance. So in descriptive statistics, you're describing your data using numbers that summarize what you observe. So for example, out of 10,000 participants completing a survey about exercise habits, you could use descriptive statistics to summarize instead of explaining every data point for all 10,000 participants, which would not be reasonable or very likely to be able to do. Also, for what is the average number of minutes exercised each week, or what percent of women exercise for more than 30 minutes per day, these questions can be answered using descriptive statistics, specifically using numbers to summarize what has been observed. So when looking at descriptive statistics, they are measuring for central tendency. So I'll just go through some of the main ways of measuring central tendency. So the mean would be describing the middle of the data, and it would be the average value. For example, on average, participants exercise 78 minutes per week. So for the median, that would be another form of the middle value in a data set, and approximately 50% of the data would fall below and above this number. For example, the median income of participants in a survey could be $40,000 per year. And then mode, another piece of data that shows central tendency, is the most frequently occurring value. So for example, if 6,000 people exercise 0 minutes per week, the mode could be 0 minutes if that's the highest number of people exercising at that time. Here I have some graphs that show what happens when the mean, median, mode are different. So on the very top, we see a graph that is left skewed because the mean is in the middle. However, the majority of the data falls to the right. Here we have a normal distribution or a bell curve in which the mean, median, mode are all the same. And then at the bottom, we have a right skewed graph where most of the data points lie to the left. Now I'll talk about inferential statistics. So as we discussed, descriptive statistics summarizes data, while inferential statistics uses results from your data to estimate characteristics of the broader population. So we're basically making inferences based on a smaller sample size. So the sample would be the people in your study, and the population would be all the people that you want your results to represent. So, for example, if we have a representative sample of 9 individuals for a particular experiment, and we want it to represent the whole population, we would want to choose participants that specifically represent the characteristics of the population that we are trying to represent. So here we have the question, how many minutes does the average high school student exercise each week? And if we have a sample of 9 minutes, if we have a sample of 9 individuals, and the mean would be 122 minutes, if the data the data is coming from a representative sample that potentially could be generalized to a broader population, but often we want to have a larger population size, not of 9 individuals. So what we've been talking about is generalizability, the ability for your sample to be similar to the population in order to make a good estimate. So when choosing specific participants, it's important to keep in mind the age, gender, ethnicity, socioeconomic status, geography, and the number of participants. It's better to have more when possible to properly reflect the main characteristics of a population. So now I'm going to spend some time discussing how high school students can get involved in research. So one way is to email professors at a local university. You can also apply for structured or already established research programs, like I did for PIPS. There are also extracurriculars / clubs that you might have at school that you can be a part of to gain research experience. Again, you can take on non-formal school projects or independent research projects to learn more about a specific topic that you're interested in. Another way to get involved is participating in science fairs or science competitions. Often you need to make a research poster to demonstrate your findings, and this can be a great way to immerse yourself in the field of research. So that was the majority of my prepared content, but I am definitely willing to answer any questions that the audience may have or that you guys have about questions. So someone asked, are paid summer programs worth spending $6,000? It's better to not pay for summer programs. It's best to look for unpaid summer programs, specifically competitive summer programs, as these often add more value to your application or resume because it shows that you aren't just paying to play, essentially. You've been selected for a competitive program. If anyone has any other questions, I would really appreciate if you could post them in the chat. So something else that I want to discuss is that the software industry also uses research. There are user experience researcher roles for many companies that are well paid, specifically in top software companies. And the user experience researcher does observations in real work scenarios where the software in use is, for example, could be in a factory floor or an airport or hospital. And so this shows that research is not just used in basic science, but also in other fields. And something else to keep in mind is that research can be both wet lab or dry lab, and often research can be done using programming languages, specifically like R, to analyze data and get meaningful conclusions from it. So if you're interested in doing research for a company, you would probably first want to look at what the requirements are if they have specific requirements, um, perhaps age or any other prerequisites. But it definitely wouldn't be harmful to directly email the outreach for that company and ask if you could participate in any form of research. For example, you could tell them about the specific skills that you have. You may already know some specific languages, or you may have experience performing some form of research at school, and you're looking to like gain more skills. And Sunil from High School Navigator also brought up a great point that some paid programs are okay. However, there are a lot of research programs available for high school students that are free, and some that do pay a stipend for students. So I would definitely recommend students to go on the internet and even using High School Navigator's search tool to identify different opportunities, and applying to them early on is going to be really good. If you're interested in summer programs, it's best to look at the details and the eligibility requirements early on in the winter, because a lot of these applications close in early February or March, and then by then they would, like, companies or even summer programs would finalize their applicants by then. I'm interested for the people who did stay till the end. What type of research are you interested in performing? And how do you plan to apply maybe just some of the things that you learned in this webinar? For example, some ideas of how you could, if you're really passionate about research, how you could implement this could be considering starting a research club in your school. If your school doesn't already have one, you could ask a science teacher to be an advisor, perhaps someone who has a PhD or someone who has industry research or background, and asking them to maybe partner with you, and you can have meetings at school where you go into different ways of doing research. You can start with small research projects between your members, and then potentially grow the club, maybe have guest speakers who are interested in, who have research experience, and then share them with members. And another way for students to get involved with learning skills could be through like LinkedIn Learning has a lot of great ways, a lot of resources, but there are also different learning resources like the certifications that I obtained through Oracle Cloud Infrastructure. Often they have periods where you can get a free certification, and that's a way to gain skills that could help you stand out and be more qualified for research. And for the comment that was just posted, yeah, all of the information on High School Navigator is definitely legitimate, specifically for the summer programs, and I would recommend them. But again, I would say explore all of your options and apply to whatever is available in your community, looking at what programs are offered by local universities or any nearby areas for research, and then definitely applying early to these programs. And another way to get involved in research is as a participant. For example, you might know students at a university who are conducting specific trials, and be you might be able to be a participant in the research, and you can often even get like stipends or some form of an incentive for participating. I would say that being a participant is helpful because it also allows you to understand the other side of research, not just as the researcher, but the participant and how the experiences. This can give you valuable information on when you do research, how to make it best for the participants and make it easiest for them. If anyone else has any questions regarding research, they can put them in the chat. I would also appreciate it if you could type in one thing in the chat that you learned from this presentation that you didn't know before. I know some people were from different grade levels and different backgrounds of their understanding of research, so it would be great to know how this has helped you. Okay, so there are a few questions in the chat about high school navigator research programs, and for research specifically, what are ways to conduct fairs or competitions? I would probably say it would be easier to participate in a competition rather than hosting it, but that can also be done maybe in school. But for participating in competitions, you can go online and look for nearby science fair competitions that are available and sign up and participate. These are often great because you can collaborate with other people and work on a project together and then submit that and present your work. And then for the research programs and High School Navigator, you can try using the source that is available on High School Navigator. I can try and look for the link for that. So, for advice on how to conduct research, you would probably want to ask an advisor or someone that can guide you because it would be difficult to do everything independently. But if you could ask perhaps a teacher at your school or maybe a professor at a local university if they could help guide you in terms of conducting research. But if you wanted to do something at a more independent level, I would recommend starting with identifying a topic that you're interested in, and then going online to specific sources that have lots of literature currently posted, like PubMed or Google Scholar, and then reading the literature currently available on it to participate in research, and then you could perhaps write literature reviews on it. For conducting fairs and competitions at school, you would probably also want to partner with an advisor, and then at school you could have maybe like smaller competitions, and you can have a specific goal and have students create a poster on a specific topic and have maybe judges, or you can kind of incentivize it as a competition and have maybe like rewards for people who place top three. For conducting fairs, you could send out an announcement to your school in like the school bulletin or school messages that you're interested in conducting a fair, and that any students can submit a research project, and if it like meets certain criteria, it can be displayed at a fair that you host, perhaps on a Saturday in like your school's gymnasium. But you would probably want to contact an advisor or teacher at school so that you can gain more access to how you would to the specifics on how you would perform this fair. I hope that helps give you a little bit more of an idea of how you would go about doing it, Darshi. Did you have any other questions about the research and conducting the competitions? Yeah, that I understand what you're saying. And for high school navigator, specifically using it to find research opportunities, you can go in and add your parameters for what you're looking for. Specifically, like if you click on internships or summer program, you can see that it pops up different opportunities that can allow you to participate in research. Some of them are free as well, like the Stanford Artificial Intelligence Laboratories Outreach Summer Program. And it gives all the parameters for what the current grade is and what the duration would be, as well as how to apply. So I definitely recommend using that search tool to look for different opportunities that may work for you. But other than that, if anyone else has any other questions, they can put it in. But that was all for my presentation. Um, One last thing I did want to share is that we can connect on LinkedIn if anyone is interested. So thank you everyone for listening to my presentation. I hope you found it helpful and you were able to take away something from this. If you have any questions, you can send them to ysp2@highschoolnavigator.org. And I will also put my LinkedIn profile in the chat if anyone's interested in connecting. Regarding the recording, I believe you will all be able to have access to it once the live presentations are over. It's usually posted on the High School Navigator website. Yeah, so you can see the videos of them online on High School Navigator. And yes, I'm sharing my profile right now. Okay. Okay, you should all be able to access the High School Navigator search tool to look for research opportunities as well as my LinkedIn profile. Thank you everyone for attending this webinar. I had a really great time presenting and I hope you also found it useful. Thank you.